Hi, in this video we're going to develop a boundary scan test that is including a CAD Netlist, and we're going to do that with JTAG circuit test software. In addition, we'll use the same test board that we used in our previous video. So here is the board. Again, it has 4 JTAG devices, Xilinx JTAG devices, including a CPLD, DDR memory, LEDs, switches, and is connected via a ribbon cable from its test access port tap to one of the ports on a USB JTAG controller, the Flint Systems on-tap controller, and it will run up to 30 megahertz with 2 ports. So to get started, let's first check the controller's panel. That's just showing us that the controller is attached and it has 2 ports. Allows us to set the TCK rate and some other things. But what we'll do to get going is click on the Applications button, select a new project, and in this project folder, CT Net Starter, we'll select it, and it has the BSDL files, the boundary scan description language files that describe the implementation of the JTAG devices. So we will also include this netlist. It's a Xilinx style netlist, and it lists all of the components and connection between component pins on the target test board. So we'll select that, and then we will click OK to get it going. And one thing compared to the previous video, all of the components, because we have a netlist now, all of the components are red. So the netlist was translated, and we have all of these components. And if you don't see this when you open your project, then let support at flintsystems.com know, and we'll make sure we get a netlist translator for you. Currently, there's about 24 popular styles of CAD Netlists that are automatically translated. So again, what we have is a list of the BSDL files, and you can drag and drop them over to the JTAG Logics column, and in that column they can be dragged and dropped into the correct JTAG order. But an easier way, if you're connected to your board, is to just click Auto Detect, let the software figure out which JTAG devices are on the board from test data in to test data out. Add these detects to the Logics list. They will have a default reference designator for each device, and since we know the board, we can come in and just edit in place the correct reference designators. E1. So that will do it. We now have the JTAG chain defined the way that we want, and clicking OK will create a model for the JTAG chain, and we're almost ready to go. But what we should do first is check the power and ground nets in particular. So let's go in our circuit list here. We'll go to nets. So we're going to order the entries by nets, and let's just scroll down a bit to find ground. Okay, so to get the nets in the order we want, we have to first click the alpha here, and Now we can scroll down and look for ground nets, which we see here. And what we'll do is we'll select these nets and assign them as ground nets. Now, this is important. Once you have the net list, the software will try to find its way through all of the circuit paths. So if you don't define the ground in the power nets, it's kind of going to get lost in the myriad of connections there. So it's this is quite important. We'll go down to the VCC types of things. And here we see a number of nets that should be power nets, so we'll just call these power nets. And for now, that should do it. There may be more, but let's just go with that. We are now ready to run some tests. What we can do is go back to the logics list just to check some things. If we click on a component, we'll get a list of all of the pins on that component in this pins panel. The other thing that you can do is for controllers, the default is 9 megahertz and clicking save adapter file. So if we wanted to change that, we could change it here. And but for now, we'll just go with the 9 megahertz and click back to our circuit. And we will click all pins to run a test. Hi, in this video we're going to create a boundary scan test and also run it. And the test will include a circuit netlist, a CAD netlist. And we will use the JTAG circuit test software. And we will also use the test board that we did in the previous video. So this is the test board, and it includes 4 Xilinx JTAG devices, including a CPLD. It has DDR memory, it has LEDs, switches, and some other items that we're going to use in some of the videos. The board is connected via a test access port tab and a ribbon cable to one of the ports on a USB JTAG controller. This controller will run up to 30 megahertz. It has 2 ports, and in the software you can have as many controllers as you like, depending on how many boards and JTAG chains that you have. One of the things to check initially is in the controllers panel that the JTAG controller shows up to, it has 2 ports showing. And to get going, we will click on the application button up in the upper left. And this is going to be a new project. We have a project folder which contains BSDL files and a netlist, so we'll select the folder. The BSDL files should show up here. And again, these BSDL files are from the vendors of the JTAG chips on your target board, and they will describe the implementation of boundary scan on each chip. We're going to use a netlist, so we click on this netlist button. And at this point, we're ready to go. We won't do anything with the bill of materials for now. We'll just select what we have, click OK. And what shows up, first of all, is a list of all of the components. Because we have the netlist, we now have a list of all of the components. If we click on any one, it will show us the pins that are connected to it. But what we need to do is get the JTAG chain defined, And in order to do that, we see our VSDL files over in this list. And there are several ways of defining the chain. One is to drag and drop these into this JTAG logics column and then put them in the right order for the chain. It could be chains A, B, C, whatever. But for now, if we're connected to the board, which we are, we will just click auto detect. The software will detect the devices from test data in to test data out, and we can then use this button to move the JTAG chain over to the logics column, and it will show up with default reference designators, but since we know the board, we can come in and edit in place, which we'll do. Just take a moment. U2. U1. Okay, so now we have the chain defined. If there were multiple chains, we would proceed in a similar way, and you can change the chain designation and a number of other parameters, but we're going to go with this. We will click OK. And now the software is showing us the JTAG chain order. And again, if you click on any device, you'll see all of the pins connected. Now, an important a thing to do in order to get going and give the software some more information is to define the power and ground nets. And to do that, we'll order the items in our circuit by nets, and we'll also order them by alphanumerically. And then what we'll do is we'll go down, look for ground nets. So these appear to be your ground nets. We will assign them to ground, and then we will go down further and look for the power nets, starting with V, I hope. Okay. Okay, so we will select these nets as power nets and make this assignment. And this will help the software because now that we have a net list, it's going to try to find the paths to all of the connections, and we also don't want to be driving pins, JTAG pins that are connected to power and ground nets. So now that the software has that information, let's go ahead. Well, first of all, we'll go back and show some devices in our pin list, and we will click all pins. So let's see, clicking all pins will run the test, and we now have some results. So the red indicates areas where we've test is indicating a failure because it's finding some connections and it's not clear according to the net list if this is correct. So what we can do at this point is go to any one of these errors, let's say this one, and you can wiggle a pin and see if both pins follow. Are they really connected? In this case, yes, it does appear that they are following each other. So we could then say connect to this pin and correct the failure indication. That's one of the things we could do. But what the easiest way to do it is just click Learn Trace Results. So we did that. We'll rerun the test now that we've learned some results. And we're still showing some errors, so we'll scroll down to look for, see what's failing. And we have a couple of pins, the FPGA done. Pin is failing, and it's indicating a check pull-up. Let's just wiggle the pin here and see if these pins do play together. And we can also see from the netlist, U3 pin 56 is connected to U1 pin K10. But what it's the message is that check pull-up. So we're evidently failing the pull-up test. There is a pull resistor on this net. So this is the type of thing you would have to check out and see if that is a legitimate failure. For the purposes of getting the test going, however, we'll make this a little easier, and we will say no pull resistor test. And that will correct that error, or at least address it, maybe not correct it. We'll run the test again and see what happens. Now it passes. So just like that, even with the netlist, we have gone through the whole process of setting up and running a test, an interconnect test, so you can test the structure on your board, and just to see, does it catch faults? What we will do is introduce a fault by just changing a switch connection on the board and rerun the test. And sure enough, on this net dip switch, this pin is failing. So you have a nice pin level diagnostic. If we then remove the failure by putting the switch back in its original position, rerun the test, and we get a pass again. Now, just to cover a few other items, a few other controls, one of the things you can do is you can monitor signal activity on the board. So this is monitoring application mode signal activity, which pins are switching. This is good to know because sometimes the switching will prevent the test, will run even when the boundary scan is running. So you may need to put guards on the pins that are switching like this. So we'll stop that. We'll rerun the test, see what happens. We still have a pass. Another thing you can do, just to make sure you have a stable test, sometimes it's good to put some guards on pins that are controlling things that could pose some contention to the boundary scan pins on your test nets. And one way to find out where the likely problems would be is to, again, order the items in the net list by nets, let's say alphabetically, and just scroll down. Now I'm looking at DDR memory here, so anything that might enable, let's say chip select, anything that might enable it, or keep the DDR memory disabled that we can control is a good thing. So we click on the chip select here, and it shows us the pins, one of which is, if we look at I/O, is a U1 pin. U1 is one of the JTAG devices. So let's go to the pin constraints and drive this output high. It's enabled low, so it's active that way. And we could go to the other chip select. and do the same thing. Oops. So what we want to do again is drive this output high since it's active low. And with that, we could now rerun the test. And it's still passing. So that evidently wasn't a problem, but potentially on your board it could be, so it's something to watch for. The other thing, there are some controls here, like you may want to, so we'll reselect logics, you may want to check some pins, or wiggle some pins. You can take any pin at any time, wiggle it high, wiggle it low, it'll show up here. And you can just test selected pins. You don't have to run all of them. Let's just run that pin. So this U3 pin 8 is connected. It's showing that it's connected to pin 24 as well as pin 20 on the same chip. So in addition, it's showing the clock activity on the board. It's also showing pins that are at a constant value, and it might say you want to just sense these inputs high. Since they always stay high or low, you can elect to do that. So that's a control that you have. And as far as, say, this connection, we just ran a test on this one pin. We'll do it again. We can say, well, why did it show connections to U3 pin 24? So bear in mind, what's happening during these tests, I haven't really mentioned this, is we're broadcasting on every pin. So we just selected this pin this time, but it's broadcasting a signal, and this is where that signal is being detected. So it's showing all your detected pins. So you might wonder, well, they're not directly connected, but we have the net list. So we know it's pin 8 is connected to R136, so we can trace back through R136 and see where it goes. So we trace back and forth, we browse back and forth through the net list, and we see, okay, well, this path took us eventually to U3 pin 24, which is showing there. So having this net list available and the ability to browse back and forth helps you to diagnose any problems that you might have when creating or debugging a test, and it shows you your circuit at a glance as well as the test results. So the other thing you can do is you can run a tap test. We'll create a tap test. And we ran a tap test, and it's showing a fault. I'm not sure exactly why. So if we create a tap test, and then we can run the tap test, and this will tell us for each device the ID codes that it found, whether it passed or failed. And it's probably a good idea to run this initially rather than after you've done the interconnect test. But at any rate, that is a thorough test of your test access port. It also will measure the number of cells, so that's a good indication that you have correctly defined the tap. Some of the things that you can do, if you want to, you can refine this test. You can go to any device, select the opcodes that you want to use in the test. There are options when you run the test. You can do an initial state reset, final state reset, measure the BR, boundary register length. So these are items that are under your control, and there are defaults, but they are something that you can change. And if you have certain protocols that you need that enable JTAG circuits on your board, or that you need to run on your board, you can use the script capability to specifically control pins and scan data inputs to your tap. So any preconditioning that you need to do, you should do here. You would define the script that controls this information. You set the script up under the script window, and we'll describe how that's done in some detail in another video. But that is how that's done. So the other thing, when you close your test, if you go to Solutions, it will show you. I have a number of test projects here, but in your project folders, it will show you the last thing that you've run. So if you click on that, it will take you back basically to where you were, and you're ready to go testing pins. Okay, so we'll call it quits here, and in subsequent videos we'll take a look at some of the other features, how to run set up script files, and a few other things.